Hello and welcome back to the channel. Apologies for such a delay in between videos, but a lot was going on with personal life, with end of year vacations and family and career and all kinds of fun stuff. But I'm excited to get back into it and get our next video going. Last time when we had a video, we went through and created a sample application, just a simple REST endpoint to invoke to make sure our service was listening and active. We're going to be building that up in future videos, adding in calls to actually do business stuff. But for now, for this video, I want to get a code pipeline set up in AWS. So this is going to be a little bit of DevOps work, getting a nice pipeline to where the end goal, whenever we make some changes, add in a new endpoint to our application, put in any new code, I want to be able to merge that to master or commit to master and have a build automatically be kicked off in AWS, build a jar, deploy it to an EC2 service, and let it just run and listen and be live out there right away. So it should be pretty fun. So our goals today, in order to do all of that, the first step is to make our sample application an executable jar. So last time we just did a Maven Spring Boot run. So Maven ran the code for us, which worked fine locally. In order for this to be usable in AWS, we need to package that as a jar. That way it can be executed on an EC2 server and then have that work for us. So after we do that small piece, then we need to build out a code pipeline. So we're going to be using our AWS admin account to fill out all of those pieces for a pipeline. So it's going to listen to our code commit repository on our master branch. There'll be a piece that will build our application. There's parameters that tells it how to build, depending on if it's Java or Node.js, C, whatever the library and language is. You can dictate how you want it to build it and then how to deploy it. There's variations in all of those pieces, and we'll talk through a little bit of differences as we go along. For our purposes, we're going to do code commit, code build to build our application with a jar. And then for our deployment, instead of using code deploy, we're going to use CloudFormation. So CloudFormation is another service that AWS uses to provide an environment for you. So it does a lot of the back end things. So it'll create your EC2 instance, do all the security configurations for that, simple security configurations for that. It'll build out an elastic IP address for you. It'll have an environment where you can pass in environment variables, things like that. So we'll be doing all these pieces behind the scenes for us. So we use CodeFormation as our deployment service. After we get all that done, we want to have our code pipeline run and see if it deploys successfully and test via our Postman tool that we use. So let's get to it. So step one, pretty simple. We need to get our application to be compiled as a jar. For this, it's basically just a POM update. So there is a plugin that you can use, a build plugin that will build your code as a jar. And that is org.springframework.boot. And the artifact we'll be targeting is the Spring Boot Maven plugin. And then we need to give us some configuration details. It'd probably be easier to copy paste this chunk, but just want to kind of go through one step at a time. So this says which Maven goal to execute on, and then the next, well, same execution. So the goal to execute on, and then a little bit of configuration for it. So it needs to know how to determine where your main class is for it to know how to start. So we're saying it's going to be a Spring Boot application, and the main class is com.autotrader.app. So this will tell it where to look for the main class to execute when you try to execute the jar. And I believe those pieces is all that we need. So I want to see if this worked. So Maven clean, we'll do package, and then give it the goal repackage, because that's what we specified, and see if it's happy with that. So building everything out, build success. We should have a target directory. Inside here is our client library.jar. So if I do java-jar and say where this is at, Windows does not like me. It should now try to execute our jar. So we'll see if that works. So it looks like it's loading up our Spring Boot application. I already have found something on port 8080. Don't know what it is, but I can't bind to it. So it crashed, but that's fine. It at least shows that we have an executable jar. So that is step 1 complete. So we have an executable jar. So now we're going to switch over to AWS and start setting up our pipeline. So I've already logged into the console. We're going to use our admin account. We're going to do admin things. So go ahead and log in. Just to kind of go a quick overview where we're at before we do things. That way we can see what all has been created for us. If I go to S3, so far we have no S3 buckets defined. If I go to EC2, EC2 is the compute layer for AWS. That's sort of our application server. There's no running instances, no Elastic IPs, no anything. There's only a default security group that's given to us when we create an account. Other than that, we have no EC2 instances defined or running. If I look at just all instances, it should be all empty, right? So no EC2 running. If I look at CloudFormation, this is going to be our environment. That's going to be set up for us. There's no stacks created, so that's all empty. Elastic Beanstalk is another service that's going to be doing the actual deployment for us. So this is a quick and easy way, easy service AWS provides to deploy your applications. And this is the getting started page. There's no applications defined, so that's all ready to go. So I think that's all of the service we'll really use. Well, one more. So we'll look at IAM later. It's going to create some roles behind the scenes for us, which is our security, allowing our code commit, our code pipeline, code deploy, and the EC2 instances all communicate with each other. Without that, then if if you don't have the policy set and the roles set up, when your code pipeline tries to deploy to an EC2 instance, if that security hasn't been set up, it will say you're not authorized to deploy or do anything to the EC2 instance. But again, using the CloudFormation and Code Pipeline and Elastic Beanstalk, all those roles, everything's going to be set up for us. So it'd be less interactions on our part for that. All right, so let's jump over to Code Pipeline and start setting up our actual pipeline. Again, there's nothing in our pipeline, no builds, no deployments. We do have some repositories which we've been using. So we have the AutoTrader repository that we'll use. So go back to pipelines, and it's a nice clean slate. Click on Create Pipelines in the upper right. We will give it a name. So we'll say AutoTrader. You can usually edit many things in AWS after creating it, but this specifically says once we create it, we cannot edit it. So keep that in mind. Service role, we'll allow it to create its own service role for it, and this would be the role name it'll create. So it looks good. Defaults will be fine for now. We're going to have AWS manage all the security keys, encryptions, all that fun stuff. We don't need to do any of our own custom encryption keys so far. So this all seems good. Next, step 2, this is your source. So you can choose to have your source be code commit as its own Git repository within AWS. You can also use Amazon S3, so you can listen to an S3 bucket for any changes to that bucket. If it detects any changes, then it'll kick off a pipeline. That might be good if you're doing like a static website, like HTML pages, JavaScript, things like that. So whenever you overwrite any JavaScript or HTML or add HTML pages to your S3 bucket, it'll detect that and deploy it out to your web server. You can also do GitHub. So GitHub is very popular with developers as a public repository host. So you can actually configure your AWS pipeline to listen to your GitHub repository for changes to kick off builds. You can have webhooks communicating any changes from your GitHub account to AWS to kick off your builds, which is really cool. But for us, our code is in code commit. So we'll select that. Repository is AutoTrader, and the only branch we have right now is master, which is fine. There's a couple different options on detecting changes. We're going to use the CloudWatch events. So whenever there's a commit on master, it'll send a CloudWatch event over to CloudWatch, and Code Pipeline will be listening for those events, real-time streaming events. Alternatively, you can have AWS Pipeline check every once in a while to see if there's any changes. It's less real-time, but it is an option if you so desire. So we'll do the CloudWatch events. All right. So now we need to say how you want the code to be built. So we're going to do CodeBuild. We haven't defined any projects yet. So we're going to have it create a new project and pop out for us. So we'll create a project name. So we'll do AutoTrader Builder. This is our build step of our project for the AutoTrader repository. We don't need any tags at the moment. This will set up our build environment, this next section. So if you want your own like Docker image and saying this is how I want you to build our applications, say it's like a C application or Node.js, or you have these other dependencies, and you have a Docker image already built that will build your code base, you can do your own custom images. For us, it's just a basic Spring Boot application, so we'll have a image that's managed by CodeBuild. We'll have it built on a Linux 2 operating system, standard runtime. I guess we'll just go with the latest version. We'll keep all these same defaults. This will also create a service role to allow CodePipeline and CodeBuild and all that to communicate with each other and communicate with the instance to build, all that fun stuff. This will be the role name it will create for us. Take a quick peek at some additional configurations. So I didn't show this at the beginning, but part of the AWS free tier is, at least I know for the first 12 months, you can have a free pipeline that's active at all times. And the additional pipelines will cost fee, but we only need one pipeline, so that would be free. For CodeBuild, I believe you get 90 minutes per month of active build time. So if you go over that build time, they'll charge you probably hourly rate of your build time for your project. So you can set some timeouts on your builds. So we'll use this a little bit. This is a very small, simple application. So I would say like a build, start to finish right now, it shouldn't take more than probably like 10 minutes. Probably won't take even 5 minutes. So we'll do 10 minutes for now. So if it takes longer than that, we'll just time out and kill the build. That will help reduce the risk of any costs. If we do lots of builds over and over again, it'll at most take 10 minutes. And then I'm the only developer on here, so there's not going to be a lot of developers adding builds to the queue. So we'll do, just in case we have a couple back to back, we'll do like, they can be queued for 15 minutes. So if a build is ongoing, it'll hold the next one in a queue for 15 minutes, and then it would probably time out. So if you are still building and it's been sitting there for more than 15 minutes, it'll just not do that new build. So those we'll do for timeouts. VPC, probably do just the default VPC, the least amount of compute memory. These all can stay the same, all the defaults. The next piece to note is, I kind of mentioned before, but CodeBuild allows you to dictate how you want your application to be built. So a Java application will be built differently than a C application or a Go application, so on and so forth. AWS has a special file called a build spec that you commit to your repository that gives different hooks and different commands you can run to say, this is how I need you to build my application. So we will use a build spec file. The other option is to do build commands probably inline here to say, just run these commands to build application. But for us, we'll use a build spec file, and that'll have some different hooks that you can add in our own commands at each stage of the build process. And for our purposes, our build spec would be very lightweight, very simple, and easy to use. But you can, if you want, build out a very complex build spec on step by step. This is each piece I need you to build. You can say what the build spec name is. By default, it'll just be called buildspec.yaml, and it'll be at the root directory. So it will be under the AutoTrader. There'll be a new file here called buildspec.yaml that we'll add in when we get our pipeline set up. But you can overwrite that configuration by saying this is the build spec name and its location in our repository. Again, we'll just use the default logs. I don't think we need to worry too much about logs. But we can, if we want, it's optional. Right now I would probably send build logs to CloudWatch, and we can group them and name them different ways to better organize our logging output. And we might revisit this later on if we get into more of a production ready status. That is all of the steps that we need for our code build step. Alright, so green check mark, good stuff. So we have a auto trader builder project now in CodeBuild. You can add in environment variables to your builds. So we actually will come back to this shortly, later on in the video. We'll need to actually overwrite the port that our server starts up on for our Spring Boot application. The default is port 8080, and just how AWS sets up some of the routing, we need to overwrite that and have listen to port 5000. Just a random, I guess, quirk about AWS. That's how they set up different things. For now, our build stage will be complete. The next step is our deployment step. So we have different options on how you want to deploy our application. There's an actual code deploy in here, and that will give you like ultimate fine-grained control. So it's basically you have another app spec.yaml file in your code base, just like the build spec has different hooks in to run different commands. You can also do the same with code deploy and have different hooks and different commands, and say if you have an EC2 instance already running, you can say this is the EC2 instance to upload to your code, and at the stages of the upload process or the deployment process, run these Unix commands. And you can have different scripts that you can code in step by step how you want your environment to be set up and run. Right now our application is super simple, so we don't need that fine-grained control. I believe we want to go with CloudFormation. Is that correct? What is Elastic Beanstalk? I think we'll do Elastic Beanstalk. So again, this is a deployment service that AWS provides. But I believe we need to pause this and go ahead and create our Elastic Beanstalk application. So it doesn't have an option to pop it out to create it. So let's do another window. Sign in again. Go to Elastic Beanstalk. So here, top right, create a new application. We'll say AutoTrader backend. This is our backend services. Go ahead and hit create. So for Elastic Beanstalk, you can actually set up different environments for your application. So you can set up like a dev environment, QA environment, production environment, so on and so forth. So we're going to create a new environment, be a web server. So this is good for web APIs, which is states, web applications, websites, things like that. Worker environment, I believe, is more for like batch processing jobs and things of that nature. But for us, we need a web server environment. Our environment name will say AutoTrader backend env dev. So in case we have a production environment, we'll do a prod environment. For this one specifically, it will be a dev playground for us to use. This is the, I guess, URL that it will be bound to. And if you leave this blank, it'll auto-generate some randomized value here for your domain and end it with .useast2.elasticbeanstalk.com. So we'll leave that blank and just let it auto-create stuff for us. Our platform, so it tells you kind of what your deployment environment is, like what kind of environment you're playing in. So for us, it's a Java application, so Spring Boot app in Java, so we use that. You can get started with either a simple application. So when it first creates an environment, create a sample application, upload to you to let you see it's alive and healthy. You can upload and start use an existing version if you want, and you can select from that drop down, or go ahead and upload your code as you make this either zip or WAR of what your application is. So we'll just do a simple application. It's going to get overwritten in like 10 minutes anyways once we do our first code pipeline deployment. But just hit create, I think it's create. And now it's going to give us some logging. It'll take a little while. It's going to be creating all of our back-end services that we need. So it's creating all of the EC2 instances. Don't know if I mentioned in the past, but Elastic IP. It's going to create one of those for us. Elastic IP is an AWS way to handle cloud environment IP addresses. So whenever you create a EC2 instance, it has a IP address, right? So you need to use to connect to it, clients listen to it, so on and so forth. If you get rid of or terminate or stop that instance and then restart it, then you'll actually be assigned a new IP address from a pool that AWS manages. So you're never guaranteed the same IP address in between stopping and starting your EC2 instance. So to get around this limitation, there's an Elastic IP address. So even if it starts up and has a new IP address, it'll be associated with the Elastic IP address. So that if you go to that Elastic IP, it'll be routed to your EC2 instance. I guess that would be the best way to explain that. And it's already created that guide for us. So if we go to this IP address, it will be routed to our EC2 instance for our AutoTrader backend dev environment. So, and again, it's created a security group that does some security communications to do some defaults there. It's created a S3 bucket to store environment data. So it's creating all of these services all for us. That way we don't have to do them all by hand, which is really convenient and makes things easier. So next one is the EC2 instance. So it's create an EC2 instance behind the scenes for us that we'll take a peek at in a little bit maybe. And it's launching that and it's associated that instance to our environment. On the top here, this is our URL. So once our environment is green and stable, this URL should be our application running live for the public to consume. which is cool. So successfully launch environment. So if we go to that URL, we should see a nice, happy website. Congratulations. It's all been deployed. It's running an EC2 instance. The URL successfully was routed to our EC2 instance. All security was all updated to where it's publicly accessible. All that fun stuff. So we have an environment for our application. If we go back to the AutoTrader backend, this is environments that we've created. So we see our dev environment, and we can go to it, and it has some health statuses, and it says what platform it's running on, what version it's on, what version of our application is running, I should say. So if we have, at some point, we'll probably version in Maven, whenever we do major functional changes and bug fixes, things like that, we'll bump up our app version. Then it should be it will deploy it and see what version is running in the environment, which is really handy to have. You can pass in configurations, which we will be doing in a bit. Again, for that, what port to run on. And just monitoring and health checks and all kinds of real-time data that it provides us. So again, Elastic Beanstalk, you just create an environment and it does all of this back end and tying things together for you, which makes it super simple and easy to get stuff out there and running. All right, so back to our pipeline. I'm hoping, just switching back to Elastic Beanstalk now, we have our application that we can select and the environment that we created. Hit next. This is a review. This is all of the settings and steps that we went through. So that all looks good. Hit create pipeline. And this should create our pipeline. I believe it does a new pull from our repository and tries to build our application. I would expect it to fail because we didn't add a build spec yet, so it doesn't know how to build the application. This is a nice little view of our pipeline. So it's looking at our source. So it's pulled from code commit. So we have our security set up, or it set up our security to be able to communicate with code commit. It's now trying to build our application. I would expect this to fail, again, because we didn't specify anything in a build spec file on how to build it, so it doesn't know what to do. It might actually time out. Might just kind of wait forever. And then assuming, yep, so it failed. You can see the details and get more logging, all that fun stuff. Assuming this had worked, then we'll go on to the deploy stage and deploy our application real time to our environment. And once we add in all these steps, we'll watch it go through and actually deploy our application, which would be cool. So next step. So I guess it'll still be in part 2, but we need a app spec, or a build spec rather, .yaml file. So we'll go back over to our project. Add a new file, build spec.yaml. This is the root level of our project, which is the default location it looks for it. So that looks right. All right. So this YAML file is going to contain lots of hooks and phases, and we can tell the build process what to do at each step. So first, they have a version of which build spec this is, and I would think you can look at the documentation on AWS to see what features are on different versions. So there's different phases that these are our hooks. So this is going to say what to install for how to build the project. So we need a runtime version, and we're building a Java project. And I believe this is our runtime version to use, so that should be good. So this next hook is before it actually does a build step. After it installs it, you can do any other commands you want to set up environment things. For us, we're just going to do an echo in pre-build phase, nothing to do. Next is your actual build phase. So for these commands, we're going to echo build stage started at, and then you can actually do a few things. So you can pass in the date, and I believe these are tick marks. So pass in the date, that way when we look at logs, we can see when this build actually was performed. So now is how do we actually want it to build applications using Maven. So Maven package Spring Boot repackage. So this is the Maven command to build our artifact. And that should be all the commands we need to build. So our post build, we'll do build finished at date. So this will give us kind of how long it took to build our application. So those are all of the phases. So the next piece in this build spec is specifying what your artifacts are. So if you're building different things different ways, you might have different artifacts. It might be JavaScript files, it might be jars, might be a war, ear file, any type of artifact that your output for the stage is. So for us, our artifact is from the target directory. It's the default. When you do a Maven, it's going to put it in target. And it is client library -1.0 snapshot.jar, which is our jar they built. So just our target directory in the file. That is our artifact output. And then it'll take these artifacts, so you can have a big list of them if you want, and it will upload all of these to an S3 bucket. Usually zip them up, and doesn't really have a pretty name for the S3 file, so we can probably change that at a later time, but for now it'll take this jar, it'll zip it and upload it to S3 bucket, and that'll be the input to our build stage in our pipeline. So the output for our build is sent to an S3 bucket, and that'd be the input for our deploy is that same S3 bucket. So that should be all that we need. So get status, there's just the one file. Commit adding a build spec file for AWS Pipeline. Actually, did I? Nah. Stage that first. And then commit it. This also has the POM change for our jar. So git push. Alright, so that looks like that worked fine. So we should have our repo updated. So I'm going to sit back for a moment and see if our pipeline actually detected that change and kicked off a build automatically. So refreshed. Our source, this is our comment that we add. That succeeded, and our build is now in progress again. So it automatically seen a change. That hook worked, and now it's trying to build our jar. So it looks like we might have a little typo somewhere. Can I find expected colon at line 14? So line 14, we missed a colon. Simple enough. Fix that typo. Type, whatever. Doesn't really matter. A typo in the typo message. Ironic. Alright, so let's go back to our pipeline. The source is in progress again, so again I detected a new commit. So I was able to get that commit, and now it's in the build stage once again. Look at the details and watch the logs in real time as it tries to build our application. Alright, so lagging a bit, but so it's getting further. It's actually able to read our YAML file and start executing commands. Looks like it's downloading all of the plugins and dependencies that it needs to build our application on. So phase complete. So build success. It looks like all of this worked fine. Enter the post-build phase. Running this command, so actually tells us the date that it completed. Upload artifacts succeeded. So this was the artifact it uploaded. So everything looks great there. Go back to our pipeline. Now should be the deployment stage. It actually says it succeeded, which is great. So we'll go over here, look at our environment, says our health is okay. So let's open up Postman here and see if we can hit this guy. So for now we'll do the entire URL. Hit send. I'm thinking it'd be a 502. All right, I kind of expect this. So this could be due to a few things. One possibility is we deployed our application, but it was an executable jar, so it just kind of crashed, didn't know what to do to run whatever artifact we gave it. So it's nothing running behind the scenes here to listen on. That's probably not the case because our health is okay. So it looks like it's able to communicate just fine with our application and detects that it's running. If it's not able to communicate with our application, the status will actually change to degraded. That is an indication that our application's health is in a bad state. It's not able to receive requests, or it's in some state that it's not able to process. So the other possibility, which I believe is going to fix it, is the port that it's running on. So sort of how AWS routes different things, it will go from our URL, this guy, to our environment, and our Beanstalk environment will forward that request to our application on port 5000. That's just a default behavior on how AWS sets up their routing. We haven't changed any configuration details for applications. So our application is starting up on the Spring Boot default port number, which is port 8080. So it's listed on 8080. Elastic Beanstalk is sending the request on port 5000. It's never making it to our application. There's a couple ways we could fix this. So one option is inside our client library project, we can add in a resources directory and then add in application properties and configure application to start up on a different port 5000. And then it will just, whenever you start the application, go to start up on port 5000 instead of the default port 8080. The other way to do this, which is the path I'm going to take, is actually configuring this specific environment and how it's going to start up. So if we're in our dev environment configuration, I believe it would be under software. We can pass in environment variables to our application. So we can pass in the server port to be 5000. And hit apply. So now it's updating our environment. It's resetting all of our services and instances to take that new change into effect. So it's going through, if we had 10 EC2 instances for this environment, it would go through each of those instances and update those applications. For us, we just have the one EC2 instance by default. So it's updating that EC2 instance with that new configuration setting. And this shouldn't take too long. So it'll give some logs every once in a while. So it's updating, it's on this first instance out of 1. Again, if you add 10 instances, it will show you as it updates each one. So health is now okay. is able to update the instance. So if we go back to our Postman without making any changes, send the request again, we get our endpoint message. So successfully invoked endpoint, running tests, and then this is all from our controller, recall from the previous video. So this is hitting our endpoint, running this code, returning back the string, and it's getting here. So this is showing we did a real-time environment variable change our application, and AWS just knew what to do and applied that change to our application in real time, and we just sent a new request and got a successful message back. Good times. So one last piece. Instead of doing this very long auto-generated name, I'm going to find the actual Elastic IP address and use that. It's just a much shorter name. And while we do that, let's go through and see what all has been creating for us behind the scenes. So we were in CloudFormation, we've seen that. Our S3, we should have one or two buckets, probably two. Yeah, so there's a Elastic Beanstalk bucket, which is our configuration details for our environments. So it has the environments and runtime, and a lot of this we don't need to worry about, but this has all been generated for us behind the scenes and managed by AWS. So these are probably each of our deployments in Elastic Beanstalk. The other bucket that was created for us is our Code Pipeline bucket. So it has our source artifacts that was sent to our build server. So it took our code commit, I believe it packages it all up in a zip file and sends it to the build server that we configured. And then it takes that, unzips it, and builds that code, and then uploads that built artifact in this zip directory. So if I were to download this and unzip it, it will have our executable jar in there. And then this is what is the input to the deployment stage. So the output from Code Pipeline, or the code commit, is input for code build, output for code build is input for code deploy, and it's nice and clean and easy. And this was all, again, created for us behind the scenes. We didn't have to go in manually create these, manually create the security details and permissions and bucket policies. That's all been created behind the scenes for us, which is great. What else would have been created for us? EC2, we were going to look at that. So our EC2, we have a running instance. So this should be our application, right? So it's running, listening. It said t2.micro by default, which is great because that's within our free tier usage. So we get basically a t2.micro size instance always up and running for a month. For every month for free. If we add in more instances, so more than one instance or a larger compute size than t2.micro, it will be charged that fee for that usage. But for us, with this experiment of ours, the t2.micro is free for us. It also has the Elastic IP address, which should be this guy. So if we go back to our dashboard, Elastic IPs, it created this Elastic IP and associated to our application. And again, this was all done behind the scenes for us. Elastic IPs, I believe, I don't know if you get unlimited for free, but at least a few, I think like maybe 5 Elastic IPs for free of charge. As long as they are bound and in use. So you cannot go out and request like 1,000 Elastic IP addresses and not pay anything for it if they're not using them. because that is going to take IPs from other applications that AWS could give to a different application, right? So there's a limited number of IPs, and so as long as you're actively bound an instance to that IP address and it's being used, then it would be free for us to use. For instance, if I were to go to the EC2 instance and kill that guy and keep this IP address in our account, it's not being used anywhere, it's not being bound and alive, so it's going to start charging us a usage fee because we're not using it, which is kind of ironic to think about. But in any case, we have a Elastic IP. We don't have any load balancers at the moment, but you can set up a load balancing if you have 3 EC2 instances and you have requests come in from one source. You can have a load balancer to go in and split up your load to handle large spikes in traffic and such. And I believe you can set up environment configurations to do all that for you if you want, but our default, we don't need any load balancers. Default is just one EC2 instance and one Elastic IP instance, and that's all we need. What other services would it have created? I believe we gone in and created our Beanstalk application ourselves, so it's still alive and healthy. I guess one thing we can look at real quick is configuration. This is where you can configure some of these security groups and probably how many instances to create and how to deploy things, which is good control if you need to kind of ramp up applications and scale your environment out. Load balancer, this is kind of talking about, you can set up your environment to define a load balancer to handle your traffic for you. Yeah, everything is pretty straightforward. So this is your instances. So you can define your type, so your size, what image it has on it, if it's a single EC2 instance or if it's a load balanced instance, how many, so if you're load balanced, right, you can actually say have at least 3 instances running and go up to a max of 5 instances. And you can set up different, I guess, alarms or metrics to say if I'm using 80% of my 3 EC2 instances, go ahead and spin up another instance and scale up to meet the demand of that traffic. And then if you go up to 4 or 5 instances as your max, and then your traffic starts to bleed off and your CPU usage goes down to normal 15% or 20%, then it will scale back your application to your minimum amount. So that's a lot of good control that you're given by AWS to say how you want to scale your applications. You can do cost savings there to have that control on not having things go crazy and scale up 1,000 instances and you're paying for 1,000 EC2 applications. So, kind of rambling now, but it's kind of walk through some of these services that I created for us. So we looked at our Elastic IP address. The last little test is replace that with our Elastic IP, send a new request, and that should work fine. I guess a fun little test, I guess. Let's make a code change. We'll say if pass equals 0 and fail. So if we didn't run any tests, we'll say result plus equals, so we concatenate on warning, no tests, run. So we'll just do some random code change. We might muck around with this later, but if we didn't run any tests, we'll add a little warning message to the output. And to test service output. Push this change up and we will see our pipeline kick off. So it's in progress, and we'll watch our Elastic Beanstalk environment as well. So seeing that change, it zipped up those source files sent to our build server. So it kicked off a build server, doing the build now, so we can watch that. So again, some of these commands that we configured in pre-build phase, nothing to do. In build phase, with the time that it started. Downloading all of the plugins and dependencies, maybe dependencies for application. Upload complete. So that stage should be done. Send the deploy stage. So we should see this status change. Yeah, it will be nice to update to get a better version number. So we'll do that as another little side video. Actually, did it already complete? We'll see. Send warning, no test run. So we made a code change, and within like a minute and a half, 2 minutes, it's already deployed application and is live. So we were able to hit it and get our change. And I believe that's all of our goals for today. So we added a plugin to our POM to make an executable jar. We built out a code pipeline and all the pieces for it, the code build project, that cloud formation application and environment. We updated our port that we bind to with the environment variable within our cloud formation environment. We create a build spec.yaml file to say how it builds it, all those pieces. We deployed our application a couple times now on our pipeline, and we were able to hit it with Postman in real time. So that will wrap up this video. So we have a nice clean environment now that we can deploy to and test future changes. So our next video, I believe I'm going to start making some actual real code. Again, like the overall project is creating an auto trading software platform. So I'm going to be using Robinhood as a first brokerage company, I guess. And they have some APIs. It's not technically public APIs, but they are exposed nonetheless. So I'm going to try to find some of those endpoints to consume, send out to actually get interactions with their production API. So I should be able to log in to my account, do trades if I want, look at what my account status is, what kind of positions are open and closed, all those things within my code hitting their API. So the next video I'll probably create our first endpoint invocation as a client. So it's going to go and reach out to Robinhood with maybe like a login. So log in with my credentials, go get a token, come back and see if it gets that token. And we'll add that to our test services endpoint to run it as a test to see if it works, and we can invoke that via Postman. I might split it up into a couple videos with all of those pieces, that way it's not too long. We'll try to do some unit tests in there, maybe do test-driven development as part of this. But yeah, so that'll be our next video. As we add in more client service calls to Robinhood, we're going to start doing some refactoring at that point and making a factory within Spring, which is cool little pattern to use. So we'll have a factory that will say, I want to use this call to Robinhood in this part of my code, and just inject the factory, call it, give it the payload I want to send, and receive back the response. So we'll create a nice little factory that does all that, and we'll just keep on adding more pieces to our application and getting it more stable. So if you enjoy the video, if you learned something, like, subscribe, all that fun stuff. If you could leave a comment as well, I do read those. Just let me know how the video was, if it's easy to follow along, any questions, any stumbling blocks that you might run into, let me know and I'll try to help y'all through that. But I believe that is all for today. So thanks for watching, and I'll get back with y'all next time.